Welcome to electrification, guys. Today we're going to be studying Ohm's law. And Ohm's law basically states that voltage is equal to current times resistance, otherwise known as V is equal to IR. Voltage will be in volts. We have current in amperes, resistance in ohms. And this is basically Ohm's law. If you have trouble remembering the formula, you can think of it like a triangle. V on top, I and R on the bottom. If you're covering V, then you're trying to solve for V. V is equal to IR, cover V. If you want R, cover R. V divided by I, current, is equal to R. Likewise, cover I, V divided by R is equal to current I. Okay guys, let's solve some simple circuits using Ohm's law. We have a battery here and a resistor here. Let's say a 10 volt battery, plus side, minus side. We'll say this R is equal to 15 ohms. We can use Ohm's law, V is equal to IR, and isolate for the current. Current is going to equal V divided by R, which is going to be the 10 volts divided by the 15 ohms. That will give you 0.75 amps. And that will be the current going through this circuit. Another example, guys. We have another battery, but this time we have two resistors in series. Let's say we have 10 volts here, plus side, minus side. R1 is equal to 10 ohms, R2 is equal to 5 ohms. R equivalent will simply be R1 plus R2. That is 10 plus 5. 15 ohms would be R equivalents. And I would simply be V by R, 10 volts divided by 15 ohms. We get 0.75 amps of current going through this circuit. Likewise, guys, if you have another battery, plus side, minus side, and another resistor here, but this time we have it in parallel with another resistor. We'll give this one a value of 5 ohms. We'll give this one a value of 10 ohms. 10 volt battery. R equivalent will simply be R1 in parallel with R2. And R1 in parallel with R2 is equal to 5 R1 times R2, 10. And then 5 plus R2, 10 is equal to 50 divided by 15. We get an R equivalence of 50 divided by 15, which is 3.33 ohms. So then we can solve for the current going through this circuit, as V is divided by R is equal to 10 volts divided by 3.33 ohms. We get a current of approximately 3 amperes. I is equal to 3 amps. Similarly, if we have another battery, we'll give this 15 volts minus plus, and let's say we have a resistor here and another resistor here. And let's say we have another resistor here and another resistor here. We'll say R1 is 5 ohms, R2 is 10 ohms, R3 is 15 ohms, R4 is 1 ohm. Basically, we can go ahead and say Rx is these two guys, and we can say Ry is this, and Ry is simply going to be these two in series. R3 plus R4, which is 16 ohms here, and Rx here we have simply R1 5 plus R2 10 15 ohms. These two are in parallel. If we draw the new circuit, we have the 15 volt battery. We have the 15 ohm resistor here, Rx 15, and then we have 16 ohm here. We'll say this is now R1 and this is R2. And we have V is equal to this. We can solve for the current. V divided by R is equal to 15 volts divided by these two guys in parallel. So let's find the R equivalent right here. R1 in parallel with R2. So R1 in parallel with R2 is simply 15 times 16 divided by 15 plus 16. That is equal to 15 times 16. 7,440. So you can see we have a large resistance here. I'm not going to get much of a current. 15 divided by 7,440. Yeah, so the current is approximately 2 milliamps here.